Ever wondered how a single entity can exist in many forms, especially in the realm of computer science? Well, you're about to find out. Welcome to a journey through one of the four pillars of object-oriented programming known as polymorphism. Polymorphism, a term derived from Greek, where poly means many and morph means forms. In the context of computer science, it is a concept where a name can denote objects of many types, and allows expressions to denote entities of different types at runtime. Step 1. Understand the basics. Polymorphism comes in two types: compile-time and runtime polymorphism. Compile-time polymorphism is also known as static polymorphism, while runtime polymorphism is known as dynamic polymorphism. Step 2. Dive into static polymorphism. This occurs when the object's functionality is set during compile time. It includes overloading concepts, method overloading, and operator overloading. Method overloading is when multiple methods have the same name but different parameters, while operator overloading is when multiple operators have the same name but different parameters. Step 3. Explore dynamic polymorphism. This occurs during runtime when the functionality of the object isn't set until the program is run. It includes two concepts: method overriding and virtual functions. Method overriding occurs when a derived class has a definition for one of the member functions of the base class. A virtual function is a function in a base class that is declared using the keyword virtual. Now, why does polymorphism matter? It's all about making it easier to handle complexity by allowing the same interface to control access to a general class of actions. It boosts the flexibility and interoperability of programs. For example, in a system with many types of objects, polymorphism can simplify the definitions of complex systems and make them easier to handle and more adaptable for future changes. Additionally, polymorphism allows objects to be treated as their superclass type rather than their actual type. This can be useful in many real-world situations, such as when creating objects that share certain characteristics but also have unique features. In summary, polymorphism, one of the foundational principles of object-oriented programming, is all about one name, many forms. It grants flexibility, promotes system manageability, and boosts efficiency. It's like having a universal remote that can control multiple devices. Each device is unique yet controlled in a similar manner. Polymorphism is a vast topic with many intricate details, but hopefully this has given you a clearer understanding of the core concept. Remember, the beauty of polymorphism lies in its ability to handle complexity with grace and adaptability. It's a powerful tool in any programmer's arsenal, so wield it with wisdom.